For the first part, we are all using a single interest rate compounded per the period, which is annually. So for all these cases that we are writing in here, the major assumption is that over the lifetime of the project that we are discussing, the interest rate does not change. It is compounded and it is annually. So I and N representing the years, the number of periods, and the I compounding is all the same. We are using the terminologies of P, F, and A. So in our examples that we will do for the first time, we are going to consider a cash flow between 0 to 15. 15 years. A payment right now at year 0. This is year 1, this is year 2. To find an equivalence of this payment at year 2, the idea is, what is an equivalent value in here? That is equivalent to this, really moving it to this. So we are talking about two different cash flow. One is this, and one is this. They are really equivalent, because this one, we found its future worth at year 2. That idea simply can be achieved by using the proper factor. That factor is F given P, I and N. So what is the future worth of this value? F is going to be P, F given P, I, and 2. This is the value, the equivalent of this in here. It's like saying, if I move this to this year, what would the value be? And in this case, this is the value. Now let's say this is year 9. Let's call this F1 and let's call this F2. P, F, P, I, and 9. Simple. Same thing. You're moving, so you will be using this F given P factor, and so on. Now, the question is there a relationship between F1 and F2? Yes. Can we say F2 is P, F, P, I, and 2 times F, P, I, and 7? Yeah. Make sense? In this case, I moved it here, and then I moved it here. This is the value as a result of moving to year 2. And this will convert this value to year 9. Remember, this was F1. So there is a relationship between them. Now let's look at F3. Now let's look at F3. F3 is at year 6. At year 6. So what is F3? 3 different ways that I can write F3. One, I can just move it to year 6. So it would be P, F, P, I, and 6. That's one way. What else I can do? I can move it to year 2 and then move it to year 6. So I can write it like this. FP, I, and 2, and FP, I, and 4. What else I can do? I can move it directly to year 9 and then take it back to year 6. So this is equivalent to P, F, P, I, and 9. And then, okay, P, F, I, and 3. Can you write it in another way? You can move here, you can move to 9, and then move back to 6. So these are all options. It's moving. Depends on whether you're going that way or you're going this way. And of course, you know the relationship between P given F and F given P for the same I and the same number of years is that they are reciprocal of each other. One is 1 over the other. Okay? Or generally, if you multiply them by each other, you get 1. That's clear. What if I want to find an equivalent annuity for this? Equivalent annuity over the whole period of this number means that you are planning to find this. 1. You're planning to find an equivalent of that number in here. Okay, so these do not exist at the same time. This will go away, becomes this. That's the equivalence. So that and that. How would this become like that? In this case, this is the P. The series is, that's the standard for. So you will be using P given A and A given P, which are the reciprocal of each other. So in this case, I have something right now. I have a P, and I want to find its equivalent A. A is going to be P times these two values. 1, you put them on the numerator, 1, you put them on the denominator as a option for you to memorize what you need. You want A, so A has to be up there. You have P, so P has to be down here. That's how you can memorize what needs to be done. And A. This is going to give you this value. This is A. So this is going to give you that value. What does A mean? It means that every year from here to here, you have a payment of this much. If A is $100, it means you have 15 payments of $100 each. Just like the mortgage that you pay, or just like the car payment that you pay, and so on. When you get an answer for that, this representation means this. That's what it means. It means that you have this many payments, they are all the same value. That's what annuity means. Same payment over that many years. What if you have something like this and want to find its present worth? If you have something like that and you want to find its present worth, then the only thing that you need to do, this time you're looking for P. And what you are given is the value of A. You say there's an annuity with this much value, so you will be using A. And in here, so this will be P and A. I and N. So if I want to find the present worth of this value is going to be P, and it is represented by this. In the individual payments, you're only dealing with one payment and another payment at another year, so you can actually see how many years it is. You always start with 0. Whether the payment is here or whether the payment is here. You always start counting from 0. You say this is 0, this is 1, this is 2, this is 3. That's how you count. So if you want to find the future worth of this at this point, then the counting begins from here. If you want to find the future worth of this number in here, then the counting begins from here. That is 0, 1, 2, 3. This will be 4, 5. This will be 6, 7, and 8. Counting begins from where you want to move them. When you are moving back, you have to make sure that the point that it is coming back is always 1 year prior to this on the cash flow. If I have a series like this from year 10 to year 15, I want to find its present worth at time 0. What do I need to do? I need to be using the formula, but this formula converts this to this point, which is 9. In reality, what you are saying is that you are converting this value to the start of the year. Okay, this is year 10. This whole space is representing year 10. So converting a set of cash flow, which is equal from year 10 to year 15, it converts it to the start of year 10, which is the end of year 9. So that's how you do the conversion. So in this case, if I am looking at the P at 0, then I have to first find P at 9 using A is given, P given A, I, and you start counting. This will be your 0. That's 0, 1, 2, 3, 4, and 5. Okay? So this will be 5. This is equivalent at time 9. Now I have to move it again back to here. So you say P0 is P9, that value that I calculated, and what? Now it's one single payment and I need to move it to year 0. So this is now like an F trying to go to 0. So this, in this case, I have this value, which is the P9, times what? Times P, F, I, and 9. 6 years. So from here, both these numbers have to end up to be that number when you count it. So in this case, it would move back to year 9. And from year 9, it will move back to move it back to year 9, we will be using this. And then to move it back to year 0, we will be using that. Let's make it a little bit more interesting. Let's say that I have, and I'll put numbers in there. Let's put that I have $1,500 now, year 15. And I would like this to be represented as 2 annuities. One from 2 to 9, and from 10 to 15. How would I do this? Well,
it just looks like it's a space, right?
It looks like there's a space there.
But
It means there is a payment at year 9, there is a payment at year 10. There is a payment at year 11, there is a payment at year 8. What does that mean? It means it's a payment all over. So when you have it like this, 1 year, it's really like that. This is year 3, this is year 4, this is year 5, this is year 6, this is year 7, this is year 8, that's year 9, this is year 10, that's year 11, that's year 12, that's year 13, that's year 14, and that's year 15. This is like a annuity from the start to the end. Okay. So how would I convert this? How would I convert that to this?
So you break is equal to, now you got to bring it to 1 first. Yeah, bring it.
You have to bring it to the year 1 first. Why to year 1?
That's where
Because the year 0 for this is really
year 1.
year 1. Okay? And then it goes back there. In this case, we want to move it to year 1, and then we want to break it over that. Okay? Again, the idea is to be efficient, to realize that this is efficiency. Otherwise, you're dealing with you're assuming that there are 2 separate series in here. Okay. So in this case, 1,500, A will be 1,500, move forward 1 year, it's going to be F given P, I, and 1. This value is now at this. Is this value larger than 1,500 or smaller?
Larger.
Larger. As you go forward, as you go to the future, it becomes bigger. If you come back, it becomes a smaller. Okay? So this is the value at year 1, and I want to break that over this many years. So what would that be? It would be A given P, I, and 14. This will give you a value for A. You might get something like this, 1500, 1500. What is the equivalent to? Two to 7 and 9 to 15. So you might get something in like this in your homework. How would you do this? We are trying to find A. We're trying to find annuity, and in this case they are both the same. This is the best way that you can do it. The most efficient way that you can do it is consider this as just one complete set. And what does it miss from one complete set? Is a 1 year in here. That is what is missing. So add that and subtract that. Add $10, subtract $10, you get $0. That's just what is in my pocket.
No, that is my question. I understand to make it a full annuity. That's my idea as well. But my question comes where we don't know what A is.
Well,
So how?
we'll work with that. We'll work with that. Okay? We'll work with that. So we have the 1500. We have the 1500. And we don't know what A is. A is this value. That's the most efficient way of doing this. If that is A, this is going to be A. What about this?
Minus A.
That's the value is A when you consider it as minus A. Our present worth is 1500. And 1500 is equal to what? That series. We don't know what the value of A is. Multiplied by what? This is equivalent to this. What should this be? What is this? Present worth at 0. So what should this be? It has to be the same thing. So you can set them equal to each other. So this thing has to be the present worth at the year 0. So how would you convert this thing to a present worth at the year 0? You say A for, this was 15. That was 15. So what would this be? This would be P given A, I and 14. That is this right here. But it needs to move 1 year again. How would you move that? P given F, I and 1. You can get all these numbers from the table. So this is a number. You multiply them, you get 3A. What else? Now subtract this value, which is A, and it is P given F, I, and 8. That's the value you get from the table. multiplied by that. This is a value, you multiply them and you get 4a minus 2a. You subtract them from each other and you get 2a.
Okay, but
2a equal 1500. And from there you get the value of a. Okay? Why don't you get your tables and give me those values?
what's the interest rate?
12%.
I don't know.
You took my table, so you didn't do that.
PFA 14 is
6.6282. PA 14. Okay. PF1.
PF1 is 0.8929.
8929. PF8.
Is 0.4039.
4039. Multiplying these two numbers, what do you get? 4 decimals only.
5.9183.
5.9183A minus 0.4039. Subtract them from each other. A is equal to 5.51. 5.51. 4. Okay.
That's A?
A. That is 4 point. Now you can say A is equal 1500 divided by 5.514.
272.
272.03. Okay. Not difficult at all. $1,500 again.
A is different.
1,500. This one is twice that size. This is A. This is A. This is 2A. The simple way was going to be bringing this to here, to year 2, and from year 2 to bring him to year 0.
Simple way.
That's a straightforward way. That's a straightforward way. Then you convert this to year 10, makes sense? And move it to year here. Do I get a straight answer? No, because there are A's involved. But this one is 1A, this one is 2A. But multiplied by a bunch of factors. Now let's do one more of these. I have 1,500. So I'll move this to year 2 and then move it to year 0. I'll move this to year 6 and then move it to year 0. I'll move this to year 11 and then to year 0. I will write the equation. It will be a longer equation. These will be positive, this will be negative. I add them up and I get a statement with a missing A in it. Then set it equal to 1,500 and yeah, I get a value. Any question?